Okay, it's Mr. Ackley here with a quick video to show you some two-step stoichiometry problems from your notes. This should help you review both for tests and complete assignments given. I want to start by reminding you that your flowchart we copy down in the beginning of the unit is very useful here. If you recall, it went something like grams of A converting into moles of A, which could be converted into moles of B, and then finally in the third step converted into grams of B. Whoop. That's not a good B, but I think you get the idea. And then if we only want to do part of that, you could very easily just do certain sections. So for example, we will only be completing the first two steps. This step here first, and this one second. I have two sample problems that do these two steps, and then two others that do the next one. But we'll start with this one. You might find it helpful to follow along, not just with your fill-in-the-blank notes, starting on page 2, I believe, but also with the flowchart side by side, so you can see how everything is used or follows that same flowchart. So, moving along here, every single one of these problems you'll always have a chemical equation with coefficients. You see there's 1 in front of the CO2, 2 KBRs, 2 KCl, and 1 Br2. And you always have a question. And the key is knowing what you have and what you're given, what you're asked for. So you're given grams here, and you're asked for moles. So anytime you're given grams, that is instantly your grams of A. And if it asks for moles of a new chemical, notice KCl versus KBr, you know you're going across into your second step, moles of B. So essentially, you're converting from grams of KCl into moles of KBr. And what we don't know are these question marks here. So we start with our given, 3 grams of KCl, and our first step is to convert into moles of A. Now the way the conversion factors work is what you want goes on top, and what you're given goes in the bottom. In this circumstance, our given is grams of KCl. So that means I have to divide by grams of KCl. And what I want, moles of KCl, goes on top. Now if you follow your flowchart, you'll notice the 1 always goes here, and there is an indication for periodic table on the bottom. So this number right here, 74.6, is going to be variable. It depends upon the chemical. And the number just above it, this 1, is always the same in this step. So when I have moles on top, grams in the bottom number comes from the periodic table, and the top is always the same. Now KCl, if I look on the periodic table, add up the molar mass of K and Cl, that's where 74.6 comes from. You can try it on your own. And then when I do the math, 3.75 times 1 divided by 74.6, I get 0.05 moles of KCl. And I've completed my first step. However, I'm not done, because I do not have moles of KBr like I want, I just have moles of KCl. And it's useful to keep in mind that these units cancel out. So whatever step I'm on, what I'm given always has to go in the bottom so it cancels out. Alright, so I'm one step in. I'm at moles of A. Grams of KCl, got to convert it into moles of KCl. For my second step, I can take that same value, my answer, bring it down, and now if you look at the top of the screen here, I have to convert to moles of B. Now my B chemical is given in the problem. So your B chemical is this guy right here, KBr. You're always told that in the problem what to convert into, so whenever you're curious, that's what you look for. So what I want goes on top. So moles of B is what I want. My B chemical is KBr, that goes on top. Moles of KCl goes in the bottom because that's, again, what's here. I have to cancel it out. Now notice the numbers here are not 1. I had said that 1 goes in front of moles. However, that's only for the first step involving moles and grams. Down here, when it's a mole-to-mole conversion, just like we did with the mole ratios in class, I have to look at the coefficients. So the coefficients are up here. So you'll see 2 is in front of KCl, and you'll see a 2 in front of KBr. So the 2 from KBr is the one I use right here, the nifty little arrow, and this 2 from KCl comes down all the way. Let's see if I can get this guy to connect right down to there. Just so happens at the same number. If this number in front of KCl was 3, 3 would go on the bottom. Now once you have that, you do the math. 0.05 times 2 divided by 2 gets you the same number again because it's a 1-to-1 ratio. And again, it's always useful to note and remember that these units have to cancel out. So whatever you're given here has to go in the bottom. And now I have my final answer. So once you've got your final answer, you're done. And I'm in the units of what's asked for, so moles of KBr, and that's a good step for me. So that is one complete example. I'll pause for a second to make sure you have everything written in the way it should be. Okay, let's go to the next one. This next sample problem is the exact same format. It is going to be a grams of A converting to moles of A, then converting into moles of B, and then I'm done. It's another two-step problem. So let's look. I'm going to go a little quicker through this one. You'll notice the key points. You'll notice I'm given grams right here. Sorry for the sloppy pen work. And I'm asked for moles here of a new chemical. H2O going to C3H8. So essentially 27 grams of water converted to moles of C3H8. My equations are set to go with coefficients that are balanced. So I start with 27 grams of H2O, and the first step, same as the last problem, is to convert it into moles. So what I want goes on top, what I'm given goes in the bottom. This 18 again comes from the periodic table, and 1 is always in front of moles when I'm in the moles to gram step. I do the math, 27 times 1 divided by 18, and I get 1.5. And again, same as every step that we do in these kind of problems, your units on the bottom have to cancel out. Alright, you're one step in. I'm from grams of A, my A chemical H2O, to moles of A, H2O. I take that moles of A, H2O, and I have to convert it into moles of B. So what I want, my B chemical, is C3H8. Comes right from the word problem. C3H8 is the B. In some worksheets, you'll see instructions that say the underlying chemical, that's your B chemical, what you want to convert into. So what I want goes on top. So moles of B, C3H8, go on top, and moles of A go on the bottom. H2O goes in the bottom. Now the 1 and the 4, right here, 1 there, and the 4 here, come from the coefficients way up here. See if we can get this little arrow up here. And then this 4 up right here came all the way from this guy right there. So you got to look in your equation for this step. So 1.5 times 1 divided by 4, it's a fraction, 1/4, is 0.375 moles. So I'm canceling my units out. The units at the beginning of each step have to be canceled, which means I can't have moles of H2O on the top and moles of C3H8 in the bottom. And the coefficients have to line up with the right unit. If you're talking about moles of H2O, then you got to have the 4 down here with it. You can't have 1 in front of it. and moles of C3H8, it's got to be a 1, not a 5 or a 3. Has to be that. So again, to review, first step, from grams of A to moles A, use the periodic table. Second step, moles of A to moles of B, use the coefficients from the chemical equation. Okay, that finishes this quick video on converting in 2 steps from grams of one chemical